Hello friends, welcome to Math Opera, myself Salil Gadgil. In this video, I am going to explain the concept of median of a triangle. I am going to show you how to construct it, all its properties, as well as I'll clear a few misconceptions related to it. Let's get started. So in this segment, we are going to discuss about the median of a triangle. We are going to discuss its properties, how it is constructed. So assume that I have a triangle ABC as shown over here. You can draw this triangle on your piece of paper. Now what we have to do is, we have to locate the midpoint of segment BC and join that midpoint with the opposite vertex. So if I consider the segment BC, the vertex which is opposite to BC is vertex A. So what I would be doing is, I would find the midpoint of BC, I would join that midpoint with vertex A, and that becomes a median. Now how do I locate the midpoint of BC? I could simply construct the midpoint of BC using a perpendicular bisector. So how do we construct a perpendicular bisector? We take a measurement which is more than half the measurement of BC. So let's take that measurement. So keeping my rounder on C, I take measurement more than half of BC, I mark an arc above and I mark an arc below, right? Then with the same measurement, without changing the measurement, from the vertex B, I mark another arc above the segment BC as well as below the segment BC, without changing the measurement. So once I mark those two arcs, I find the point where those two arcs intersect. So here on the top you would notice that one arc is not intersecting, so I have to extend that particular arc. So the point where these two arcs meet, this point as well as this point, I have to join these 2 points. So I would join them using a scale, and once I join them, I really am not interested in the perpendicular bisector here, but I am interested in finding out where is this line segment intersecting the base. So I notice here that if I join these 2 points, the line is going to intersect the base BC at this particular point, and therefore this point, let's mark this point as X. This particular point is the midpoint of BC. So basically we are locating the midpoint using the concept of perpendicular bisector. Now if I join A and X, so if I join A and X, this particular line segment is called a median. So median is basically a line segment which joins the midpoint of a line segment or midpoint of the side of a triangle with its opposite vertex. Now you would notice that this particular triangle has 3 vertices, hence it is quite logical that you will be able to draw 3 medians in this particular triangle. So I have already marked the midpoint of the line segment AB. Let me mark this particular point as Y. So I am going to join C, because C is the vertex which is opposite to AB. I am going to join C with the point Y. So that forms my second median. I hope you are also trying this on your paper. So this forms my second median. Now these 2 medians are intersecting at this particular point. So if I construct the third median, it is guaranteed that the third median, that is the line joining the vertex B with the midpoint of AC, will also pass through this same point. So if I were to just join this particular point with that point, I am going to get my third median. So you would notice in this particular diagram that it is possible to have 3 medians constructed in a triangle. So this is the first conclusion that we arrive at, that there are 3 medians in a particular triangle. Now all these 3 medians are intersecting at one particular point. If you notice over here, this particular point, the point where all medians intersect, is called the centroid of the triangle. So centroid of the triangle is basically the center of gravity of that particular triangle, meaning if you have a triangular wooden piece and you draw the medians of that particular triangle, they would intersect at this particular centroid. You can actually balance the whole piece of wood or this whole triangle about this particular point. So if you hold the triangle on your finger about this particular point, the centroid, the triangle would be exactly balanced. So that is the significance of the centroid of the triangle. So medians intersect at centroid. This particular point is called the centroid of the triangle. Generally it is represented by the letter G. Now there is a special property when it comes to median. So let's consider median AX. Okay, so X is the midpoint of BC, AX is the median. Now what is happening in this case is, we know that the measurement of BX is exactly equal to the measurement of CX, right? Because X is the midpoint. Now since these two measurements are equal, the base of these two triangles is equal and the height of the two triangles is also equal. So I have explained this concept in the altitudes video, that the altitude of these two triangles is also equal, and therefore the area of triangle ABX, that is the triangle on the left side, is equal to area of triangle ACX. So what the median is doing is, it is actually dividing the triangle into two equal parts, which means if you ever have an argument about dividing a triangular piece of say cake or triangular piece of land into two equal parts, all that you need to do is you need to draw its median. So median divides the triangle into two equal parts. That's the next special property. Now when I draw this particular median AX, do you notice that the angle A is getting divided into two parts? So one part is angle BAX, that's one part, and the other part is angle CAX, that's the second part. Now these two parts need not be equal, therefore median does not necessarily bisect the vertex angle. So median is not necessarily the angle bisector. Secondly, the median is also not going to be perpendicular to the base, and therefore the median is also not the altitude. You would notice over here, it is visibly very clear that the AX, line segment AX, is not the altitude of the triangle. So I hope that this particular section cleared out all your concepts related to the median of a triangle. Now in the next section, I'll explain some more special properties when it comes to equilateral and isosceles triangles. So in this section, we are going to deal with the medians of two triangles. One is equilateral and the other is isosceles. So in case of an equilateral triangle, I have drawn an equilateral triangle here, triangle ABC. We know that each angle measures 60 degrees because that is the property of an equilateral triangle. Now what I plan to do is, angle A is also 60 degrees. I plan to bisect this particular angle A. So when I bisect this particular angle A, which is 60 degrees, I am bound to get a 30 degree here, and I am bound to get the other part also as 30 degrees because it is the angle bisector. Now what happens is, if I consider triangle BAD, I have 60 degree here, I have 30 degree here. So by the angle sum property of the triangle, angle ADB is going to be 90 degree because 60 plus 30 is 90. So the remaining 90 should come from angle D. So now you will notice that I have drawn the angle bisector. This angle bisector is also perpendicular to the base. So in an equilateral triangle, we do conclude that when you draw the angle bisector, it is also the altitude. Now is it also the median? Let's check. If you consider these two triangles are exactly congruent. By congruent, what I would mean is, I can literally, so if I cut an equilateral triangle on my piece of paper, what I can actually do is, I can construct this particular line, the perpendicular line to the base, and I can actually fold this particular triangle into two parts. So point C after folding would overlap with point B. So I have a set square here to show you that property. So if you notice over here, this particular set square overlaps with the right triangle, which is triangle ADC, as well as the same set square is also overlapping with triangle ABD. So what does that tell us? That tells us that this particular base of the set square was initially overlapping with the side DC, and now it is overlapping with the side BD as well. So can't we conclude that BD is actually equal to DC because both the sides were overlapping with the base of this set square? So that means this particular altitude and the angle bisector that we have drawn is also the median. It is dividing the base into two equal parts. So equilateral triangle is that special triangle where the angle bisector, the altitude because of the 90 degrees, and the median because it divides the base into two equal parts. All these three are actually the same. So it doesn't matter from which vertex you draw the median, it is also going to be the angle bisector as well as the altitude. So equilateral triangles have this special property that all medians are equal. So all medians are equal in an equilateral triangle. They are also the altitudes and the angle bisectors. Now let's see what happens when it comes to an isosceles triangle. So I have drawn an isosceles triangle here where PQ is equal to PR. So these are the two equal sides. Therefore QR is called the base of that isosceles triangle. Now what happens is when you again construct the angle bisector from P, that is if these two angles are equal, by congruency you can prove that these two triangles are equal or they are congruent. So what happens because of that is if I name this particular point as S, we notice that this angle is also a right angle as well as this angle is a right angle. So if you actually construct an isosceles triangle on a piece of paper and you cut it, you can actually fold that particular triangle. So point R will coincide with point Q. At the same time, the length of QS is also equal to length of SR. That means when a median is drawn from the vertex, this is called the vertex of the isosceles triangle. When the median is drawn from the vertex of the isosceles triangle, it is the altitude because it is at right angles as well as it is the angle bisector also. So just like equilateral triangles, the property holds true if you draw the median from the vertex of the triangle. If you draw the median from the points, the other two vertices, that is Q and R, then those medians would be equal to each other, but they would not be the angle bisectors or they would not be the altitudes either. So this is the special property of medians in an isosceles triangle. Now let's summarize what we have learned about medians so far. So just to conclude, a median is a line segment drawn from the vertex of a triangle to the midpoint of the opposite side. In a triangle, since there are three vertices, three medians are possible. When you draw these medians, they would intersect at a point called centroid of the triangle. The centroid of the triangle is a very important point because it is the center of gravity of that particular triangle. You can actually balance a triangle on about that particular point. When you draw a median, it divides the triangle into two equal parts. Remember, the two parts are not congruent, but area wise those two parts are equal. So when I had drawn the three medians, you would have noticed that 6 triangles were getting formed and all those 6 triangles had equal areas. When it comes to medians, they need not necessarily be the angle bisectors or they are not the altitudes as well. When it comes to scalene triangles, medians are different from altitudes and angle bisectors. When it comes to an isosceles triangle, median, angle bisector and altitude are exactly the same when they are drawn from the vertex of the triangle. Medians drawn from the other two vertices, they are equal in lengths, but they are neither the angle bisectors nor are they the altitudes. In case of an equilateral triangle, the medians, angle bisectors and altitudes are all equal and they are the same line segment. So I hope that you understood what a median is, what is the significance of a median, some special properties of a median, and I hope that this topic is very clear now. I hope that you found this video useful and interesting and that geometry makes much more sense to you now. In the next video, I'll come up with some new idea, some new concept. Do like, share and subscribe my YouTube channel and stay connected for more updates. Let's learn mathematics, let's understand mathematics and enjoy it. Goodbye.